welcome back. So thank you for completing the Collaborate board. So what is the relationship between angle A or angle B and arc CD? All right, so let's look at angle A. Angle A is the red angle. Here is the endpoints of that angle, and the intercepted arc is between those 2 points, arc CD. That's an inscribed angle because the vertex is on the circle. So that means that angle A is half of arc CD. Since arc CD is 40 degrees, angle A is 20 degrees. Angle B, here's the vertex. Here's where it intersects the circle. All right, so angle B is equal to, so it's an inscribed angle. We know the inscribed angle is half the arc, so angle B is equal to half of CD, arc CD. There we go. The measure of arc CD is 40 degrees, which means angle B is 20 degrees. So notice that angle A and angle B are both 20 degrees. And that's because they're both half of arc CD, which is 40 degrees. So if you have two angles that share the exact same arc, they're going to be congruent the exact same amount, and they're going to be congruent to each other. So angle A here, the relationship, what is the relationship between angle A and angle B? Angle A is congruent to angle B. They both measure 20 degrees. Right. The next page is some notes about that, and it is in your notes, and pretty much complete. I think completely complete. Right, so the starred part is already in your notes, so I starred that because that's important. If two inscribed angles intercept the same arc, then the angles are congruent. So if you know the measure of one, you know the measure of any and all that intersect the same arc. So if inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the two angles are congruent. Right, so we see the red arc there. I outlined it, but you know how straight these lines are on the computer. So I think I'll make it worse. So we have the red arc, angle ACB. We have the blue arc, angle ADB. And we have the green angle. Excuse me, did I say angle, arc, angle? We have the green angle, angle AEB. And all three of those angles intersect the same arc. Notice that the endpoints for all three angles are A and B, which means arc AB is the intercepted arc. Right? So we know that angle ACB is half of arc AB. You can add this to your notes. And angle ADB is half of arc AB, and so is angle AEB is, let's see if I can move it up just a little bit, half of arc AB. So since they're all half of the exact same measure, they must be all equal to one another. Now notice it says this here, and angle CAE is congruent to angle CBE. It's not so easy to see this angle here. You have to, it's sort of like when you look and it's either a duck or, you look at those pictures and you look at it one way and it's a duck, and you look at it another way, it's a rabbit. This is kind of like that. You'll look at it one way and you see the three angles that are outlined in red, blue, and green. But if you look the other way, all right, so now C and D and E are no longer the vertex. Now the vertex is at A. All right, so if the vertex is at A, we have an angle right here. Make sure I use the right sides. Yes, okay. Because there's a couple angles I can draw. So right here, we have another angle, angle CAE. And now if you look, here is angle CBE. CBE, sorry. Nice little glitch there, CBE. So notice that what if I can make that straight? What if I put the line way over here? Oops, I forgot it's supposed to be purple. And then I can drag it over. You have to be sneaky. So notice that black arc and that purple arc there intercept. Oh my gosh. The center of the board, you're killing me. It used to be just one little spot in the upper part. And some reason it's moving. I don't know why. But it's still a really good board. I just have to deal with its little idiosyncrasies. All right, so there we have arc CE. All right, and that's the intercepted arc for those two angles. Let's just add that to our notes. So angle CAE is half of arc CE. And angle CBE is equal to half of arc CE. So sometimes you got to be careful. You got to make sure you know which angle you're looking at, because sometimes there's more than one angle depending on which direction you're looking at with all those chords in there. We're going to do a problem in a little bit where it looks like it's one angle, but you got to kind of like, unfocus your eyes a little bit and see the other angle that it really is. So if you use the letters, right, and you identify, the endpoint, vertex, endpoint, the right angle, and maybe you even outline them, you'll get it. You'll get the right angle. All right, so now we're going to be dealing with angles that are that intercept the same arc. If we know the arc, we can divide the arc in half, and we'll have the angle. If we know the angle, we can double the angle, and we'll have the arc. And if we know one angle and we're looking for the other, just set them equal to one another. That's our three techniques for today, for solving with angles, angles that share an intercepted arc. And of course, these are all inscribed angles. Here's the first one, and it's in the notes. All right, so what is the measure of arc DC and angle DBC? All right, so first of all, the measure of angle CAD, right, starts at C. See, here I'm fine. Goes to A and goes to D. Except one day I'll be writing so much on the sides, and that won't want to work probably. So we can just look at that. It's got that box there, which tells us that angle CAD is 90 degrees. Arc DC, so that goes from D to C. Notice that is the intercepted arc for angle CAD. Right? It is on the endpoint. That arc is on the endpoints of the angle. So that means that arc DC is equal to twice the measure of angle CAD. And since angle CAD is 90 degrees, arc DC is 180. So don't forget to put this in your notes. And then let's do the last one, angle DBC. Right? So this arc, there's two ways you can think of it. One, you could think of it this way. You could think of it as, so here's our angle. There's the endpoint. So the green arc, arc CD, is the intercepted arc for angle DBC. All right, so that means we could do it this way. Angle DBC is equal to 1/2 of arc DC. So that's 1/2 of 180, or 90 degrees. Or we could think of it as angle DBC is congruent to angle CAD because they share the same arc. All right, so that means that angle DBC is 90 degrees. All right, so put that in your notes so you can see the different ways to solve. I think there's plenty of room. There's an entire like third of a page. The only thing else is the two next problems that we're going to do. So we did a little bit more work here, mainly so that we could talk about the relationships between the two angles and the arc, and the different ways that you could find the same measure. Right? So you could either, because they share the same arc, know that angle B has to be 90 degrees, or you could take half of arc DC, since we found that, and that would also give you the measure of angle DBC. I got two more problems for you. I think two more. Well, two more are in your notes. I got two more. All right, so this one's in your notes. We want to find the measure of angle CAB, and it tells us that BDC, so that is B, and it's very helpful, DC, to outline them. And on paper, you'll be able to outline them and actually be on the angle. You won't have any orientation problems. There we go. So there's the measure of angle DBC. Notice that BC is the intersected arc. Here is angle CAB. Right? Notice that it intercepts the same arc. Right? Now there is another angle, by the way, I'll just mention it, that other two angles that intercept this arc, angle DBA and angle DCA. So that's why it's important that we identify what angle the information is about, right? So that we're talking about the right thing. Right? But let's get rid of this, because that's not our intercepted arc. Our intercepted arc is over here. And in your notes, add that angle DBC and angle CAB both intersect arc BC. So that means, so we can put, this means therefore. So therefore, angle BDC is congruent to angle CAB. So we can just set them equal to one another and solve, because we don't know the measure of the arc. All we know is an expression for each of the angles. But we do know that since they share that same arc, those angles are congruent. So 3y minus 15 equals 2y plus 15. So now, once we solve for y, we could find the measure of the angles, and we could find the measure of the arc. And it actually asks us to find the measure of angle CAB. And by the way, the measure of CAB is going to be the exact same thing as BDC. All right, so now let's solve. Let's get the y's on one side. We'll subtract 2y from both sides to keep y positive. 3y minus 2y is y. So we have y minus 15 equals 15. Some students mistakenly say, hey, y is 0. And that would be impossible, because then you'd have negative 15 equaling 15. Remember, you have to add 15 to both sides. Inverse operations. Y is 30. Right, so now we have found the value of y. Let's find the measure of the angles. So angle CAB is 3 times 30 minus 15. That would be 90 minus 15 is 75 degrees. Let's just check and make sure that angle BDC is the same amount. That would be oh, whoops. Well, that's the one I found. Plugged it into the wrong one. That's okay. Angle BDC is, now let's find angle CAB, the one we were asked for. And it should be 75 degrees as well. So we have 2 times 30 plus 15, and that would be 60 plus 15 is 75 degrees as well. And then if they asked us, we could find the measure of arc BC, because the measure of arc BC is just going to be 2 times the measures of either of those angles. So 2 times 75 is 150 degrees. And there we have solved for y, and found the measure of the arc, the angles, and the arc. Right? And notice they are the same. It's a good way to check. Right? Just plug it back in and make sure you get the same expression, same answer. Right? And so this one should go in your notes, and there's plenty of space. I think there's plenty of space. Because there's only one more problem, and that's this one. And this is the one that I felt was kind of like an optical illusion when you look at it. This one, I don't know. It was clear which angle they wanted. All right, so to me, so don't write this in. This angle stands out. This one here, and this one here, and then this would be roughly drawn there with the little glitch. That would be the intercepted arc. But that's not the correct angle because it's LJM. So L is not the vertex. J is. But to me, those ones stand out more. So I'll do my best. L to J to M. Hey, that doesn't look too bad. And the other one, of course, has to intercept this arc. So that would be MKL. So now these two intercept the arc. And did I put the typing? I didn't put the typing, so I'm sorry. You might have to write a little bit. You can abbreviate a little bit. So angle LJM and angle MKL both intersect the same arc, and that arc is LM. Therefore, and never, this is the symbol for therefore, it looks like 3 dots in a triangle, making a triangle. Therefore, angle LJM is congruent to angle MKL. And so we could just set those equal to one another. LJM is 5b minus 7. And MKL is 3b. Let's subtract 3b from both sides, even though it's going to give us 0 over here. So 2b minus 7 equals 0. Ooh, that's a 0. And then add 7 to both sides. 2b is 7. Oops. Is 7. Here comes the 7. And that means b is 7 halves. This is a terminating decimal. If you like, I can write the first number. Why can't I make it 2? You could also write it as 3.5. Come on. Just get in with it in line. No, oh my gosh. That's never happened twice. Just get in line. Right down here. There you go. Take your place with the others. Equals 3.5. There we go. And so now we found the value of b. We were asked to find the angle. So whether we find either angle, they're going to be the same thing. Let's find them both, and then we'll find the arc too. So angle LJM is going to be 5 times 7 halves minus 7. So not exactly a friendly number, but so 35 halves. 7 is 14 halves. So that's going to be 11 halves, or 5.5. I still think working with fractions will be a little bit easier. I can subtract those easier in my head. And then angle, and this one's easy, angle, the other one, MKL, is 3 times 7 halves. Oh, I'm sorry. That is not 11 halves. Then here is where it's good to do a check. Because 3 minus 1 is usually 2. So that's going to be 21 halves, or 11.5. And if we multiply 7 halves by 3, we get 21 halves. So notice that either way, our angle is 21 halves degrees, or 11.5 degrees. That means the angle, the arc LM, let me switch colors, would be twice 11.5, or actually, let's write it in as 21 halves. Of course, the 2's will cancel, and that's 21 degrees. And so there we go. So it's pretty easy working with arcs that share the same, angles that share the same arc. Just set them equal to one another. Otherwise, all of our inscribed angle properties apply, that the angle is half the arc, and the arc is twice the angle. Thanks for watching. Bye for now.